So I also have some slides to share today, and it's come to me. My job was to manage this, so I appreciate that it's I get a little bit less time to do that. So we really see ourselves as positioned between universities on the one end and national laboratories, and on the other end, large companies and new ventures. We see this as sometimes it's called the valley of death. How do you get technology out of research labs and into the real world? And that's really our specialty. And in order to do that, we often start with new component technologies, and I'll share a few of those with you today. But we always need constant real feedback from the communities that are going to be using them. So we have a hammer, we're looking for a nail, but we don't want everything to be a nail. We want to be very realistic about that. So I'll share with you a couple of ideas, some core technologies that we're looking at. So this is actually legacy footage. So Abundant Robotics came out of our robotics group. This is work done by Kurt Salisbury. And we're using an SRI component technology, a new technology called electroadhesive gripping. And when you turn the voltage on here, you can see you actually adhere to the apple. And you do so with no normal force. So it's a very gentle way to grab the fruit. So this might have potential for soft berry picking, for instance. So you turn the voltage off, the fruit is released instantaneously. When we looked at that for apples, but when we really got into the weeds, pardon the pun, about what that looks like, apple picking is a very fast process. So the competition for all these harvesting tasks is actually pretty amazingly fast. We have humans doing oranges here, strawberries, and apples. Apples, for instance, humans do about 2 picks a second. And we heard from our panel earlier that we shouldn't be thinking too much about speed, and I think that's true. Really, it is cost that matters, but speed can be sometimes a good proxy for the realities here of what you have to, what you're competing against. Also, humans are doing this with amazing perception abilities, and they're picking fruits that are fragile and they're not hurting them. It's pretty remarkable. And so in that case, what we moved to was something more akin to a vacuum gripper idea. It's more of a vacuuming up. It's not a vacuum gripper, but it vacuums up the apples. It was a clever invention that allowed for that to go forward. So another family of technologies that we're excited about, this is an exosuit technology. That's myself there wearing the exosuit. This was developed, like a lot of our projects, it was developed for DARPA, and they were interested in it for to reduce soldier fatigue and injury. But they said to us in a classic DARPA fashion, we want the exoskeleton, but you're not allowed to do the skeleton part. And that was a really big challenge for us. And they had really good reasons for that. The reality is that exoskeletons, the skeleton part can weigh 90, 150 pounds. They can be very dangerous for the person to step inside of. And there limits the range of motion. There are a lot of problems with that. So what could we do with just the exo muscle? If we take that exo muscle or that actuator and just strap it onto the human skeleton and do it that way. And that's what you see here. In this case, it's an ankle actuator. And that ankle actuator is powering you every time you take a step. But the components we developed for this, I think, are broadly applicable for a range of things. This technology was spun out into a new startup. It's called Seismic. And they're focusing on industrial applications as well. But think of all the things that humans are already doing in the fields. Perhaps we should really be focusing on augmenting them. So you can maintain the dexterous manipulation and perception of humans. You can allow for the integration of novel sensors into the human workflow, potentially reduce injury rate. It could also make the job more appealing for both young and old. So we know that there's a labor shortage. Usually we think of that in terms of people not being available, but really people have other alternatives, right? So if you can make the job more appealing, then that can be really good. You can also collect data for immediate feedback. So you can imagine a situation where you're helping a human grade the fruit in the field using some autonomous vision, but the human does the main task. And then really the key asset between our technology and others is that the suit can actually be worn unpowered when you're not using it, and you can walk around in it. It only weighs 8 pounds and it doesn't impede your motion in any way. So the last technology I'm squeezing in here is a descendant of Proxy. Proxy is our humanoid that we developed for DARPA as part of the DARPA Robotics Challenge. And it has the unique feature of being the most efficient humanoid ever built at full scale. And we did that by really getting into the weeds and developing new actuators. And this actuator was a descendant of that. It's called Inception Drive. This is the thing that happens between the motor and the output. And this particular transmission has a really unique configuration. We call it nested pulleys that allows the green pulley here to sit inside the red pulley, even though the green pulley it turns out has an effective diameter that's larger. And that allows you to also have variable ratios, and you can do cool tricks like this, where you have the input motor spinning in one, while in this case, the output motor is standing still, and you can change the ratio. You can have the output motor go forward and reverse in a continuous fashion. This is what you call an infinitely variable transmission. They're actually used today in tractors. And so that's one market that we're really interested in, because this could be much more compact, much lighter weight. So for applications when you're worried about soil compaction, we might have a possible transmission technology that would weigh considerably less than existing technologies. And I like ending on this slide because this is our latest load-bearing prototype. And from a mechanical engineering standpoint, it's just so pretty to watch. I'm very proud of this. It's a metal compression belt that has allowed us to achieve efficiencies up to 95%. So that opens up a lot of markets in both automotive and tractor spaces as well. So that's what I have. Thank you.